Hello guys, Cristiano here. I am a C programmer, learning all those things that I can. Hit the subscribe button, let a comment, that'll help so much the channel. All my videos, you'll be in a fast mode with explanation. I'll reduce the time to be more precise. And you'll face a lot of mistakes and debugs. Everything's calculated, or not. So don't be afraid. The link for all the source codes will be in the description. If you wanna follow, just get your copy. In this video, we are going to talk about the linked list. This implementation will allow us to use this data structure for any data as we wish. It's generic. Our linked list will have a descriptor. This resource will provide us information about its size. It will scan all the list counting all the members. And it will keep all the information about the user object. In that case, the size. To see graphically how the linked list works, you can use Visual Go to demonstrate again. Here we can notice there are some operations that we can execute in the linked list. Create, very important, create the list. Search, look for an element inside the list. Insert, add a new element into the list. Remove an element from the list. These are the basic functions that a linked list can have. The remove and insert operations, we have some ways to perform. How we remove or how we can insert. The insert, we can add an element in the start, in the end, or in the middle. The remove works the same way. For our purpose here, at least in the first version, we add in the end of the list and you are just removing a specified element. Let's do some operation to see it's working. First we create a list to store the elements. Now we can add the element. Let's add 1 and see the result. Now we have 85 in order. Now we have 23 and now 31. Let's search for element 23. Now let's remove an element. 31 is gone, another 23 is gone, one more, and 85 is gone. Now our list is empty. These are the basic linked list functions. Let's start to implement. First, we start creating 3 files, the source, the header, and the test file. In the header file, we define the linked list structure as hidden, and we create 2 callbacks, the first to compare an element in the list, and the other to print the elements. Now we start to create all the functions to handle the linked list. We have the create functions to create the list. We have the insert to add a new element. We have the remove to remove an element specified by the user and will be recovered. The get, which performs the same as remove without removing an element. One function to debug. It is hard to debug the linked list. And the last, to destroy the list. Before we start to implement, we copy the basic code for another function to try to reduce the time instead to write all this repeated code. Now we need to define the linked list structure. To point to the next one, we create an internal linked list to connect the elements. It has a void pointer data and the next structure. The main structure will have an object size, the amount, and the pointer list. In the create function, we try to alloc the context. If it is good to go, we copy the information to the context and set the list to null. This means the list is empty, and we set to true. In the insert function, we try to alloc to new struct to hold the user data. If it is allocate, we try to alloc the data using the user object size and we copy the user data to the list and increase by 1. We point the list to the element. Now the element is the head. In the remove function, we check if the compare was implemented, so we get the element and create a temp to help to remove. If the element is not null, we call the user compare to allow the user analyze the element if it is the object specified to remove. If the element is the first, we point to the next point by element next, or we point the next to the element next. Then we free the element data and the element and decrease by 1. In the get, we compare the param and the compare, and if all okay, we get the head element. If it is not null, we send the element to the user function to compare the data, if it's really the data, and we copy to the user's data and break the loop. If it is not, we keep scanning. In the get size, it's simple. We just copy the amount to the user size to inform the list size. In the debug function, we test the print. If it is implemented, we get the first element. If it is not empty, we pass the user print and we point to the next. In the destroy function, we get the head element. If it is not empty, we use a temp to get the next, and we can remove the data and the element. After we add the element to the next address element, to test, we can get the partial stack text coded to start. We add the linked list to the set.h. We copy more functions and we do some tweaks to insert the data. We try to get the list size and check if it is really 2. We call debug to show the elements. For that, we implement the print that will cast the element to the person and print the name and the age. To get an element from the list, we create a recover and we call get looking for the name Jane. We need to compare. Implement, we check if the name contains Jane. We compare the names to be sure if it really is the data, and we remove the John. And we check if the list is 1. And finally, we destroy the list. We add the file to the script and we create the test rule. Compiling, we got a lot of warnings. At least has been built. I forgot here in const. Compiling testing. We got an error. The search is failing. In the name test. The problem here is use the same pointer, but you need to underscore. I have a name conflict here. I hate so much shadowing. I may have a little trouble here now. I need to fix the signatures. Now it's good. From now on, I never stop some study because I don't have the linked list. That's all for now. I appreciate it if you get here. Don't you forget to hit the subscribe button, leave a comment and share. Knowledge is not enough. Waiting for more. Bye. See you soon.